Good morning, all of you. I'll start with the efficiency of a cycle in different types of the graphs here, or what you can call like a heat engine. First, we'll discuss this. Then we'll have a paper discussion. Otherwise, what about paper discussion only? We will extend for hours together. So let me first off 1 hour, 1 hour 20 minutes. Let me do the topic syllabus. Then the remaining time, what happen? We'll go for the paper discussion. Anyway, paper I think very easy. Few are out of syllabus, I'm very sure. Okay, we do have the idea of the heat engine will come. So what is basically an heat engine? Okay, let's take this as the so this setup is heat engine. It contains working substance. So what is working substance? That working substance is an ideal gas. I'll supply heat. Heat is supplied to it. So this let me call Q positive. Net heat absorbed by the gas. Then what it does, it will do mechanical work. This is something very important. When I say work done by gas only. This one. So it's a mechanical work. And what is Q positive? Heat supplied. If you take any heat engine, when you supply heat, some mechanical work will be done and some heat has to be rejected. In a cyclic process. This is what all our engines, petrol engine, diesel engine, what all we have engines know, they do work on this principle. Examples are like we are not understanding. So when you burn petrol, petrol when it is mixed with oxygen, when we burn it, no, heat will be generated. That heat will be given to the gas, like a cylinder in which a piston and an ideal gas will be there. It will undergo cyclic process. In one cyclic process, it does mechanical work. Then a part of it will be rejected. So this is what happens in the heat engine. Tell me like which is useful, mechanical work or heat rejected?
Mechanical work.
Mechanical work.
Mechanical work. So this is what useful, no? Or this is the output, you can call it useful. Or output. And what about this? This is the input. So how we define efficiency? Output by input energy. The efficiency, the basic definition for efficiency is equal to mechanical output by heat input. So what is mechanical output? Work done by the gas. Heat input is Q positive. Okay, now let's apply the energy principle. So what we have supplied heat. Then finally what we got? Mechanical work done by Q negative. So work done by the gas, what we can write? Substituting this here, Q positive minus Q negative. In fact, it will be justified to write mod, no? Because this is heat rejected. So based on that, Though Q positive will be positive, okay, let me put mod, so it'll be easy for us. So if you want to find out efficiency, what you can do, you calculate what is the net work done by the gas in one full cycle, and what is the net heat absorbed by the gas. Take ratio of that. Or else, what happen? Or else we can also go for this one. Net heat absorbed minus net heat rejected by net heat absorbed. No. Is it possible like a Q negative will be 0? Next question comes. Can we have a heat engine where the whole of the heat supplied will get converted into mechanical? Not possible. Not possible, that one. There must be some heat rejected. That we'll see when we go for Carnot's heat engine. Why it is not possible, there we'll discuss in detail. This is just about only the efficiency of how to calculate efficiency for a gas in different cyclic process. Okay, this is about the theoretical idea. Heat engine, I'll Carnot heat engine. We have to discuss separately for that all. There we'll go for further theoretical ideas here. Now let's go for different types of the graphs. Now you if you refer the book, no, you get plenty of problems on this one, what I'm solving. So rather than solving many problems, better what will happen? Learn the methodology. This what is monoatomic gas. 1 mole, I'll take it. 1 mole of monoatomic gas undergo a cyclic process. 1, 2, 3, 4. Or if you write A, B, C, D, it's left to you. Then what is the efficiency of gas in one full cycle? So what we have to calculate? Find the if the monoatomic gas undergo a cyclic process 1, 2, 3, 4, 1 in PV diagram. I should. Okay, let's get into the thing. Now, what is a this? I think the first problem. The method is same. I think you open book, you have almost 60% of thermodynamics. All questions are related to this particular method. What I'm going to show. Different shaped. Here I took rectangle, circle will get, rhombus shape will get, but the method will be same for everything. Okay, this is the volume, the first thing. Let me write all things in detail. What is the path 1, 2 first? We have to plot equivalent graphs. So many other things are also. Yeah, we will keep it here. No, now let's come for this one. What is the path 1, 2? Volume constant and pressure increase. So isochoric heating, it should be. So, and as isochoric heating, heat will be absorbed. What about 2, 3? Pressure constant. I'm saying this one. You see that volume constant and pressure increase. So isochoric heating. What about 2, 3? Pressure constant, volume increases. So isobaric heating. Isobaric heating, heat will be absorbed. Okay, now come for this 3, 4. Volume constant, pressure decrease. So isobaric, so like a isochoric cooling it is. So heat will be rejected. What about 4, 1?
So 1, 2 should be isobaric cooling, no sir. Because pressure increases, so volume decreases.
Which one? This one, ma?
Yes, sir.
Volume constant? No, are you not seeing?
Sorry, sir. Sorry.
Huh? Okay, this one. Okay, now 4-1 pressure constant, volume decreases. Volume decreases, temperature decreases. So isobaric eating it is. So it will be rejected. Some basic idea like this. So what are the things? So first we'll go for net work done. So net work done is what, like area under PV graph, because the PV graph, no, this will be much easier. Net work done equal to area in PV diagram. What is area? This will be 3P naught minus P naught. Area of rectangle 2V naught minus V naught. So 2P naught V naught. Okay, there's a net work done by the gas in one full cycle. Okay, where all heat is absorbed in the path 1, 2 and 2, 3. This will be much easier approach. Which one, so like which formula I should prefer? Q positive minus Q negative by Q positive. Which one is very easy to calculate? Go for that. Area under PV graph is work done. So one part is over. Now what is Q12? Delta U1, and this should be NCP delta T. Like this. So what is a change in intensity of the gas in that particular process? So we don't know temperature, no? Okay, what to do now? So let's, as it is ideal gas equation. So what do we expect temperature here? Let's say T naught, 3T naught, 6T naught, 2T naught. Will I agree? How do I can write? At one, what is the pressure? At one, what is the pressure? P naught, V naught, RT1. So T1 is equal to how much? P naught V naught by R, which is equal to T naught. Next, at 2, 3 P naught V naught R T2. Shall we go for the symbols like this? This will be much easier. 3 P naught, 2 V naught R T3. And finally, okay, this what I'm just giving symbols. Like this, you can go for symbols here. Okay, let's go for delta U. What is delta U? N CV T2 minus T1. NCP T3 minus T2. Number of moles 1. Monoatomic gas 3R by 2. T2 is 3T naught minus T naught. 5R by 2. Number of moles is 1. T3 minus T2. 6T naught minus 3T naught. Okay, 2T naught. So 3R T naught. 3, 3, 3, 15, 15, 7.5R T naught. So this will be 10.5 R T naught, it will come. Okay, but R T naught, what you can write? R T naught as P naught V naught. So this is 10.5 P naught V naught. Okay, able to understand now? So this is a thing. So what is efficiency? How we define efficiency? Network done by Q positive. Network done to P naught V naught. I think, okay, this will do one thing. Let me keep in this way only. 15 by 2.
21 by 2, sir.
21 by 2. This will be better, no? Is it a very good design? Very poor efficiency, no?
Yes, sir.
If you please don't repeat again started. Gunetra, what is the problem, pa? Huh? Please
Hi, sir.
control. Huh? Please, stay away from your mobile, no? See, everyone is paying amount. It's not your own personal. I'm not your personal tutor. Hmm? Learn. There are so many things to learn. No, why you are adding chorus to teachers? Huh? What is use of that? Okay, efficiency 4/21. Huh? So this will be. It's a very poor efficiency. No, so this engine it's having a very poor efficiency. So if you have designed the engine, definitely what happen? You have to spend more amount to travel from one point to another point. So like that, the engineers, what happen? They will keep on search the new cycles where efficiency can improve and the manufacturing cost should come down. It should be very cheap. This is what the mechanical engineer will be constantly doing it. Okay, this is about the PV graphs. Can we calculate all? Can we plot PT graph, VT graph? Already we did. Once again, different. So already we have temperature, pressure, volume. So first we'll go for PT graphs. I'll take the same graph. So that will be help us to plot the equivalent graphs here. Let's go for, no. What is path 1, 2? Path 1, 2 is isobaric. So what you are plotting? Pressure versus temperature. Let's say that. There's a pressure. Please do notice very important. This what we have temperature. Temperature will start with T naught, 2 T naught, 3 T naught. No, first I identify points. So like that, sir, like there's a curve. Okay, fine. You can't draw whatever curve you want. What is the method? Identify first point. Don't bother, sir. How the shape of curve? Don't bother. Identify the points. So what is the path one? Isochoric process. So first what happened? At one P naught, T naught. Okay, identify the point. P naught and T naught. There's a point one. Later on, we'll adjust the shape of the graph. First, we'll identify. Next, again, point two. Point two is 3P naught and 3T naught. 3P naught and 3T naught. Okay, you may forget them, right? Numbers also. Next, again, 3P naught and 6T naught. Fourth one, P naught and 2T naught. What we have to do? Okay, join them. Okay, now, so like a curve like this. Okay, that's all. When you are again joining the points, you should look at the process, then you have to go for it. Is it okay? Just common sense. You have to ask yourself, okay, what shall I do? What is the method? These are the questions what we have to ask ourselves here. So now, next, what I do is like from 1 to 2. Okay, what is 1 to 2? Is isochoric process. In PT graph, isochoric process, straight line passing through origin. 2, 3, isobaric eating, horizontal line in PT graph. 3, 4, isochoric cooling, straight line passing through origin. Strictly straight line passing through origin. That's the basic condition. Okay, got this? This is what the PT graph. In books, what happen if you go for books, no? one question will be there for you, that find efficiency. One question will be there, this one. The same numerical you are doing twice or thrice, that one. So I suggest you like plot equivalent graphs. You come to know that what you are discussing for this is same thing for you. Of course, the writing formulas will be different. Okay, this is about the PT graph. Okay, let's go for VT graph. Volume versus temperature graph. Please do make observation. Some very important things will be there. What is volume V naught to V naught? So volume of the gas will be as usual, temperature T naught, 2 T naught, 3 T naught, 4 T naught, 5 T naught, 6 T naught. Okay, now identify the points. V naught T naught, 0.1. Okay, V naught T naught, 0.1. Then again, V naught and 3 T naught. Two V naught, 6 T naught. Fourth one, 2 T naught, 2 V naught, 2 T naught, 2 V naught. Okay, we have to join the curve. 1, 2 isochoric heating. 2, 3, 3, 4. But again, we have to take care what like VT graph should be straight line passing through origin. Roughly may not be. Okay, I think this curve little bit. Let me plot this one because it will give wrong idea for students, everyone. Yeah. Okay, this will be 4, 3, 2. Okay, there's a method. See, like again. Okay, look at this PV graph, clockwise cyclic process. You have to see what is it. It's a clockwise. Huh? I think I'll write instruction clockwise. It is. What about this? This is also a clockwise. What about this? This is a counterclockwise, anti-clockwise. I write it. I think very important. In VT graph, anti-clockwise cyclic process, what will happen? Efficiency will be positive. PT graph, clockwise cyclic process. Are you able to notice? PV graph, clockwise cyclic process, work done positive. Please notice in PV graph, clockwise cyclic process, work done positive. PT graph, clockwise cyclic process, work done positive. In VT graph, volume versus temperature, counterclockwise cyclic process. Then what we get? Work done will be negative. Able to notice this difference? Very important. It's going to help us a lot. Okay, this is about the pressure, PT graph, PV graph, VT graph. Let's go for one more graph is there, intensity versus density. I think let me introduce that here, that also now here only. I think I'll pull it these things here. Let me go for intensity versus density graph. Able to see things clearly? Okay, the last one, intensity versus density graph. Now, what is intensity? So let me plot or density versus intensity. Euro. but we don't know anything about the intent, you know. So whose help we have to take it here? We don't know anything about intenji. Intenji is directly proportional to temperature. So therefore I'll go for like this. U naught. Let's go for this one. So U naught, 2 U naught, 3 U naught, 4 U naught, 5 U naught, 6 U naught. What about the densities? Rho naught by 2 and rho naught. Why rho naught by 2? Because what about the volumes? Volumes will take V naught and 2 V naught. No? When volume of gas is V naught, density will be rho naught. When volume of gas is 2 V naught, density will be rho naught by 2 because overall mass should remain same. Will you agree this? Density mass is equal to density into volume. So rho naught by 2 should be equal to 2 V naught. So when volume of gas is 2 V naught, density should be rho naught. When volume of gas is V naught, it should be rho naught. So there is some overall mass should remain same. Okay, let's identify the points here now. So what is the method here now? I think let me take this graph only. Why to go for other one? Let me take this graph only. Okay, now when temperature is T naught, intensity will be U naught. What is the density of gas will be rho naught. So shall we go for the first point? Identifying the first point. This is a point 1. Then when volume of gas is V naught, the temperature is 3 T naught. So volume of gas is V naught means density should be rho naught only. And what should be the this particular thing? 3 T naught it should be. 3 T naught, so 3 U naught. Okay, therefore the point will be 3 U naught. Okay, what about point 3? 2 V naught. 2 V naught means V naught by 2. V naught by 2 and 6 T naught. Okay, there's a point. 3. So what about the point 4? 2 U naught and rho naught by 2. Okay, what about the graph? So the graph will be 1, 2. Okay, what to do? 1, 2 isochoric process, no? Volume constant, density also constant. So therefore, this is the one thing. Next, 2, 3. 2, 3 is what? Oh, I didn't plot here. Solid curve. What about 2, 3? Isobaric process. No. In intensity versus density graph, what should be the curve? Isobaric process, rectangular hyperbola. 3, 4, isochoric cooling. Again, rectangular hyperbola. Once a student learns this, he can manage any problem. He should learn the methodology here. That's all. Like this, you can keep on plot the different graphs. Pressure versus volume, we have no. Density versus pressure also you can plot it. Like that, a student has to take help of the basic geometry. There's no concept here. Your high school geometry should be very good. Okay, not only just efficiency, a student should also learn how to plot the equivalent graphs. Okay, shall I go for next one? Next, again, next shape of graph. So there's a, okay, I'll bring the PT graph. Okay, let me take the next one. P naught to T naught. Okay, this is the graph. Same monoatomic gas, 1 mole. To make things very simple, we have to calculate efficiency, plot equivalent graphs. Find efficiency in one full cycle. And we have to plot equivalent graphs. So there's a temperature, there's a pressure. This will be very important for student like what formula you should prefer. What formula is there? So the same set of formula. Okay, now what is the basic efficiency? Efficiency is net work done by net heat absorbed. No. Okay, no. Net work done. Shall we go for area under PT graph? The answer is no. Only in PV graph, area under the curve is work done. In PT graph, area under curve will not be work done. So what is the method now? Either you calculate work done in each path, calculate the net work done, or else go for Q positive, Q negative. So I think Q positive, Q negative will be preferred one. Uh, the Q positive, Q negative is what preferred one. So let's identify what is the 1, 2. Isothermal compression, temperature constant. See this. What is this? Temperature constant. If temperature constant and pressure increasing, so isothermal compression, it will be rejected. There's no other way. Student has to bring his basics. See, temperature constant, so it will be rejected. What about 2, 3? Pressure constant, temperature increasing, so isobaric eating it is, so it will be absorbed. Okay, next again come for this one. 3, 4. Temperature constant, pressure decrease, volume increase, so it will be absorbed. Isothermal expansion. So Q34. Now Q41, pressure constant, temperature decrease, so isobaric cooling. If you can, student can think this much, it's so rest all you can manage here. Okay, again ideal gas equation, because to plot equivalent graphs. Okay, here the volume of gas be V naught. So what do you expect volume of gas here? V naught by 2. By seeing only or using ideal gas equation. So this will be again V naught. V naught. Okay, so what about this? So this should be 2 V naught. So now how do you can see? I'll taking help of ideal gas equation. Let it one P naught V1 R T naught, this one. So therefore V1 is equal to what we can write it as T naught by P naught. R T naught by P naught is what V naught. I think everyone is able to think. So finding very difficult. Okay, take a notebook and pen and analyze here. Okay, to plot equivalent graphs, these volumes will help us a lot. Okay, let's go for efficiency. First, we'll calculate efficiency. What do you suggest here? Net work done. Then again, coming Q positive instead what pen? I do prefer to go for Q positive, Q negative. So what is Q positive now? Where all it is absorbed. In which all process it is absorbed? Q23 and Q34. So what is Q23? Isobaric heating, N number of moles 1. I'll write a formula. Then this will be in isothermal expansion, Nr temperature 2T naught log of V4 by V3. Okay, number of mole is 1. Monoatomic gas, Cp is how much? 5R by 2. T3 temperature T naught minus T naught R 2R T naught log of V4 by V3. So 2V naught by V naught. So directly we are going to get this as 5R by T naught, or this will be 2R T naught log 2. Okay, this is a Q positive. Straight away, see, all this within 2 minutes you're supposed to do. So therefore, I suggest you don't write story. You should able to in exam, no? A student what happened directly should able to write this equation. No need to write this symbol. No need to. So Q positive. Okay, in these two processes it is added. NCP delta T, N equal to 1, CP 5R by 2. Temperature here 2 T naught, T naught. Then isothermal process, Nr temperature of the gas 2 T naught, final volume by initial volume, or initial pressure by final pressure. Anything, since you know pressures, no, you can use take help of that also. I just indicated volume, so I'm expressed in terms of volume. Okay, what about Q negative? Q negative. Q negative will be Q12 plus Q41. Q12 NCP. So this is N temperature log of V naught by 2 by V naught plus N CP T1 minus T4. Number of moles are T naught log of 1 by 2. So therefore this will be minus log 2. Number of moles 1, 5R by 2. T1 minus this will be. So minus R T naught log 2. Okay, then what is our basic formula for efficiency? Q positive. Okay, now why that mod I'm taking? I think you can justify this. If I don't take the mod here, what is the problem arises? So if I don't take the mod, so what happens that negative of negative will become positive. Efficiency will become more than 1. Not possible. We don't have any engine whose efficiency will be more than 100%. Not possible. Means you supply 10 joules and you'll get 10 joules and 5 joules heat ejected. So from extra 5 joules from will come, law of energy will get violated. If efficiency of heat engine is more than 100%, law of conservation of energy will get violated. So keeping that in mind, this mod is brought here. Okay, able to understand now? So if I don't take mod, no, negative of negative. Therefore, this mod is adjusted here. Okay, let's see, I think now only mathematics. So this will be phi r T naught to R T naught log 2. If you want to write it, or let it be RT naught RT naught log 2 all divided by so I think 5 RT naught by 2 minus RT naught by 2 will be 3 RT naught. Oh, I think this will cancel, no? These two will cancel out. So this will be RT naught log 2 by 5 by 2 RT naught log 2 5 by 2 2 log 2. Okay, there's a efficiency. It's also very poor. Huh? Not a good machine it is. If you design like this, they'll throw you out of job. Because something efficiency is better, okay, then you'll retain your job. Kidding now? I think it's all about the basic formulas and observation. Nothing else is there. Anybody can understand, anybody can solve. Equivalent graphs, PT graph. What all graphs? PT graph. PT graph is there. PV graph, VT graph, and Euro graph. The same method. Already we have most of the information. Sir, we don't know density. What to do density? Here density, let it be rho naught. What do you expect density? Volume increase, density should increase, no? So 2 rho naught. Density rho naught. Here rho naught by 2. Okay, agreed. Overall mass should remain same. Okay, let's go for the equivalent graphs here. So first PT graph I have. Let me go for PV graph. Let me keep this in hand so that plotting will be easy for us. Huh? Yeah. First one, the equivalent graph, PV graph, pressure versus volume. What about the volumes? Volumes will be minimum V naught by 2, maximum 2 V naught, no? And the pressure is P naught, 2 P naught. So P naught, 2 P naught. So rho naught by 2, rho naught. Volumes. V naught by 2, V naught, 2 V naught. Pressure. There's a volume. Okay, let's go for first what we should do. Sir, what is there? This curve will be like this. Then teacher should break, student said, that's all. Because you are not thinking. See, that is what actually the human brain, what happened, don't wants to think that there's what like a nobody wants to put pressure on the brain, even myself also. Are you getting this one? It's not that there's a human tendency. We don't want to put effort. Are you getting now? So try to analyze yourself. Huh? You don't want to put effort. You don't want to do hard work. There is a human tendency. We have to force ourselves. We have to force ourselves. Okay, let me think. Let me put effort. So what happened? Maximum without effort, we want everything. There's a human tendency. Even for me also, what I want. Without teaching, everyone should get knowledge. And I'm teaching in such a way that okay, everyone will get a rank. Are you getting this one? So there's a human tendency. Please do understand yourself. No, you have to where I'm going wrong, what I'm doing. These are very essential. Students are thinking that something miracle will happen, they'll get knowledge. Not possible. Can I do any miracle where all my students will get a rank? Not possible. Okay, no, similarly, let's identify. What is the one? P naught, V naught, 0.1. What about 2? 2 P naught. Okay, this one. Oh yeah, here it is. P naught, V naught. This is the one. What about 2? 2 P naught. Here we are here. 2 P naught and V naught by 2. So 2 P naught and V naught by 2. So that the point should be here. Okay, no, let's come for point 3. 2 P naught and V naught. 2 P naught and V naught. What about point 4? P naught to V naught. Okay, let's now join the curve. What is this? Okay, straight line I'll bring. Okay, again, what we are we are escaping from thinking. No, before joining the points, look at again, come back and view this one. What is 1, 2? Isothermal process, isothermal compression in PV graph, rectangular hyperbola. So what is 1, 2? 1, 2 should be a rectangular hyperbola. Okay. I think anybody now? What about 2, 3? Isobaric eating, PV graph, horizontal line. There's arrow, some other color. Yeah, no. 3, 4, isothermal expansion. 4, 1, isobaric cooling. Okay, this is equivalent graph. So what I suggest, any question you encounter, plot equivalent graphs. You learn a lot. The thermodynamics will become very easy for you. There's a method of learning thermodynamics. Are you getting no? Any question, they're given PV graph. Okay, plot equivalent graphs, PT graph, all other equivalent graphs. If they're given PT graph, plot other equivalent graphs. If they're given intangible density graph, plot other equivalent graphs. So like that happens, student has to put effort in plotting all equivalent graphs. Then okay, you'll be in better position. Okay, this is about the PV. Okay, we'll go for next, the PT graph. Pressure versus, okay, PT graph already is, volume versus temperature, will go for it. What about volume? Volume will be V naught by 2, V naught. Volume, temperature. Temperatures are what, like T naught and 2 T naught. Okay, identify. Now, path 1, V naught, T naught. So, point 1, V naught, T naught. Point 2, V naught by 2 and T naught. What about 3? V naught and 2 T naught. What about 4? 2 V naught and 2 T naught. Okay, first we'll identify what is 1, 2. Isothermal compression, vertical line. 2, 3. How you represent isobaric process in PT graph, straight line passing through origin. 3, 4, isothermal. Again, straight line passing through origin. The graph, the curve should be such that straight line passing through origin should come. Okay. You check the book no you have for this graph is asking efficiency. Next, one more problem is there for this graph, asking efficiency. Again, is asking for this graph is asking the efficiency. Actually, you think that you are doing 3 problems. Actually, you are doing only 1 problem. So therefore, if you plot equivalent graphs, it understood that as even for this also, you know how to plot the efficiency. Okay, intensity versus density graph. Okay, densities are rho naught by 2, rho naught by 2, rho naught, 3 rho naught by 2, 2 rho naught. Temperature, this is U naught, 2 U naught. This is internal energy. This is about the density. Okay, let's identify the points. First, the point one. Point one, what is the density? Rho naught and temperature T naught means U naught. Rho naught, U naught. Okay, it should be 1. You see, even I too don't know how the curve. First, I'll locate the points. Okay, this is like V naught. Okay, density is rho naught. T naught means U naught. Okay, come for point 2. Density is 2 rho naught and temperature is T naught only. Means it should be U naught only. So density is 2 rho naught. So therefore the point will come here. Okay, come for this. Temperature 2 T naught. So therefore this will be 2 U naught and density will be rho naught. So therefore the point has to be here. So point 4 rho naught by 2 and 2 U naught. Rho naught by 2 and 2 U naught. Okay, we have points like this. Okay, first we'll come for what is 1, 2? Isothermal process. So isothermal process, how do straight line passing through origin? Also like a horizontal line in Euro graph, integer constant, isothermal process. Then what about 2, 3? 2, 3 is isobaric process. So rectangular hyperbola. Then it will be like this. Okay, one more. In internal energy versus density graph, you see PT graph. What is this process? Clockwise, no? PV graph, clockwise. This is a volume, no? It is. Yeah. In VT graph, anti-clockwise. At least make observation. In which process? Clockwise cyclic process work done positive, and counterclockwise process the work will be negative. I think in VT graph and Euro graph, anti-clockwise cyclic process work done will be negative. PV graph, PT graph, their clockwise cyclic process will be positive. Able to notice? I think there's a basic thing what a student must have. If you want, you can go for any other graphs. Huh? You can go for any other graph. Not only this, you can go for any other graphs here. Okay, able to get the idea? This one, how to calculate, how to get the efficiency after getting the efficiency, then how to go for the equivalent graphs here. So one more, we'll take it. Okay, PV got over, PT got over. Now we'll come for VT graph. And then we'll go for paper discussion. Volume, no? This is VT graph, volume, this is temperature. Monoatomic gas, 1 mole. To make problem very simple. If you want, you can take diatomic. Let me, later part of problems, I'll change it. Okay, now we have to calculate the efficiency of gas in 1 full cycle. Find. Okay, let's try to identify what are all the what is the path 1, 2. I'll give you 2 minutes time. Okay, student has to, and I'll have water income. Huh? Okay, now we'll go for the different graphs here. First, what is 1, 2? In VT graph, straight line passing through origin. So it should be isobaric process, no? And temperature increasing. So it will be absorbed. These are some things which I can say that one. So 1, 2 is isobaric process. So it will be absorbed. There's a question. Let me give one more. Let's have. So here we'll analyze here. So this is what isobaric eating. What about 2, 3? 2, 3 is isothermal process. So 2, 3 is isothermal process. So and isothermal eating. So here heat is absorbed. And next 3, 4. Isochoric cooling. Heat will be rejected. Let me pull it down a little bit. No, you can see this. This is what it is. Isochoric cooling. Now, what about 4? Arrow should be like this. What about 4, 1? Isothermal compression. So it will be rejected. Isothermal expansion. Isothermal compression. So area under VT graph will give work done. Answer is no. Only in PV graph, area under work done will be the net work done. So therefore, what is the alternative levels? Either you calculate net work done, so calculate the work done in each path, then take algebraic sum, you'll get the net work done. Instead, can go for Q positive, Q negative, no? So first we'll calculate the Q positive, Q negative. So what is Q positive? Where all it is absorbed Q12 plus Q23. Now what is Q12? Monatomic gas. Q12 is isobaric eating, no? So NCP T2 minus T1 plus Q23 isothermal expansion NR T0 V3 by V2. Substituting this, so number of moles Cp monatomic gas 5R by 2 T2 2 T0 minus T0. So this will be 2R T0 V3 by V2 4 V0 by 2 V0. This is Q positive. Similarly, we'll calculate the Q negative, keeping this in graph. Q negative will be, I think everyone is able to see, Q34. Just formulas, nothing is there, just only mere formulas. Q34 isochoric, so NCV T4 minus T3. Q41 it is. Q41 NR T0 log of V1 by V4. Number of mole 1, 3R by 2. T4 so minus 3R T0. Okay, taking now what is the efficiency formula? There's the one part. Okay, we'll Q positive minus Q negative by Q positive. So I think substituting these values, RT0 anyway will get eliminated. So 5 by 2 minus 3. 3R by 2. Huh? Okay, this is, yeah, 5 by 2 minus 3 by 2 will be like a 1. So this will be 1. Okay, now 2R and R. So this will be 1 plus RT0. RT0 will also get eliminated. Log 2. Check it. Is it okay? RT0 will get eliminated. Directly I'm writing it to save time. This is about efficiency. Now equivalent graphs. Okay, how to plot equivalent graphs? I think we should have the basic graph. So there's a basic graph. What I'll keep it here. So now we'll take the equivalent graphs here.
Sir,
Uh,
can you scroll up, sir, once? Sir, we will not get ln 2 in the numerator, sir.
Yes, sir.
Yes, sir.
Yes, sir.
log 4, no, it is. Oh. The log 2 will not be there. Okay, 2, 2 and 2. This will get eliminated. Okay, fine. Only this much.
Yes, sir.
Okay, yeah. It will be, yeah. Okay, now we'll go for equivalent graphs. I think we indicated. Okay, that's we have to indicate other things. Volume, how to bring pressure. So this will be pressure P0. Here also pressure will be P0 only. Am I right? What about pressure here? will decrease by 2 times. So P naught by 2. And P naught by 4. Ideal gas equation, you have to assume. So what is the method here? P1 V naught equal to RT1. So P1 equal to RT naught by V naught. Okay, agree this. So P1 equal to P2. Again at 2. P2 to V naught equal to RT naught. So P2 equal to how much? RT naught by V naught. So they should be equal to how much? Should be P naught only. Now similarly, pressure at 3. P3 volume is 4V naught equal to R to T naught. So P3 equal to R T naught by 2V naught. Okay, there should be P naught by 2. There's no much logic, nothing is there, just ideal gas equation. Okay, now you see. Okay, let's go for equivalent graphs. Okay, VT graph, no? So let me go for first pressure versus volume graph. Pressures are P naught by 4. Maximum pressure is P naught, no? P naught by 2. 3 P naught by 2. 3 P naught by 4 it is. P naught by 2, P naught by 4. There's a pressure. Volumes are V naught, 2 V naught, 4 V naught. So V naught, 2 V naught, 3 V naught. Though 3 V naught is not there, for scale purpose, I'm writing it. Okay, now identify the points. So what are the points? 1, okay, what is 1? P naught, V naught. There's a 1. P naught, V naught is a 0.1. 0.2, P naught, 2 V naught. 0.3, P naught by 2, and volume is 4 V naught. Okay, there's a 0.3. P naught by 2, no? It is 0.4, P naught by 4, and 4 V naught. Okay, join. So what is 1, 2? Isobaric, eating. 2, 3, isothermal expansion, rectangular hyperbola. 3, 4, isochoric, isothermal expansion. I think I bet you you open the material, you get so many problems just of different curves. Students will think that, okay, he's studying so many different numericals, all are same. So just now I discussed almost 12 numericals, that much I can say. Also in PV graph, PT graph, 12 numericals I completed. The graph will be, there's an equivalent graph of this one. Okay, this is about the VT graph, PV graph, PT graph will take it. Pressures same. Temperature T0 and 2 near. Let me write, no problem. This is about pressure. This is about volume V0. PV graph for no temperature T0 to T0. Okay, this is about pressure. Let's go for first identifying the points. First, we should identify points. So what about the one is P0 and T0. P0 T0. P0 T0 will be here. P naught, T naught. Okay, then afterwards, 0.2, P naught and 2 T naught, P naught and 2 T naught. 0.3, P naught by 2 and 2 T naught, P naught by 2 and 2 T naught. 0.3. 0.4, P naught by 4 and T naught, P naught by 4 and T naught. Okay, we have to plot the equivalent curve. 1, 2, 2, 3, 3, 4. This one. 3, 4 should straight line passing through origin. Should condition that is. Okay, you see now what you have in front of you? Pressure versus temperature graph here. Okay, last one, intensity versus density graph. Okay, let's take the internal energy. Intensity is U naught to U naught. What about density? Rho naught by 2, rho naught by 4. So therefore the values will be rho naught by 4, rho naught by 2, rho naught. Not may not be up to the scale. So how do you can say pressure volume V naught means density will be rho naught by 2, rho naught by 4. I'm asking you to look at here, rho naught by 2. 2 V naught. Okay, I think I can write it here. Okay, now look at this. Rho naught by 2, rho naught by 4 it will come. I think if I indicate here, you'll get confused. So let it be like this only. Yeah. Okay, now what we have is the graph. There's the internal energy. This is density. Okay, let's identify U naught and rho naught. U naught and rho naught. There is a 0.1. 0.2 will be 2 U naught to rho naught. So rho naught by 2 and 2 U naught. Okay, there's a 0.2. 0.3, 2 U naught, rho naught by 4. Okay, there's a 0.3. 0.4, rho naught by 4 and U naught. Okay, now let's come. So what is 1, 2? Isothermal process. So isothermal process, how do we represent in any graph? Let me take some other. This one, yeah. Oh, no. Sorry. 1, 2 is isobaric process. Isobaric process, rectangular hyperbola. Next, 2, 3, isothermal. 3, 4, isochoric. Then 4, 1, isothermal. You open the book, you do get all these curves. They're one of the same. Rho naught by 2. Actually, it should come here. Yeah. Okay, getting no idea. These are the method. Okay, we'll go for paper discussion because again we have. I think now I given enough idea. Please do practice efficiency. Practice as many as problems. You'll get a confidence. Then we can do the other higher level problems. Let me save this. Yeah, 4 V naught, no, volume is 4 V naught 0.4. So density will become rho naught by 4. 3 and 4 is having density rho naught by 4, correct? No, it is.